Hi guys, this is Mrs. Tallis recording your first review lesson on ionic compounds. So for this week, I don't want to do too much. I just want to review lesson 4 and 5 that we already have done and get you to go back and do a few practice questions from each section in your booklets. So here I have the notes for lesson 4, ionic compounds. And remember, we looked at the words ionic and compound. Ionic meaning it's made up of ions, which are charged particles, and compounds meaning more than one. So two charged particles put together for this lesson. We're going to have a cation, which has a positive charge. Remember, we memorize that by saying cats have pos, so positive, and an anion, which has a negative charge. So what's happening to make charges is that the metals are losing electrons, which means a negative goes away and there's an overall positive charge. And then a nonmetal gains an electron, or a negative is added and it has an overall negative charge. So what has to happen when we name these compounds is that all the charges have to balance. Now, for what we've been doing so far, we're writing solid behind all ionic compounds until we learn a lesson about solubility. Now, sometimes we have numbers like 2 and 4, and we have to make sure we write those in the lowest ratio if necessary. Here's your steps for writing your ionic compounds. You need to find the charges in your data booklet. Determine how to balance them by crossing the charges, and then we're going to use subscripts if we cross charges that are not 1. So here we have our first example, sodium chloride. If I find sodium on the periodic table, remember the first element is always going to be a metal and the second one is a non-metal. So on my data table here, I find sodium with atomic number 11 right here. And if I look at the sodium ion at the bottom, it has a charge of +1. Even though we don't write the 1, it's there. So sodium has a charge of +1. In my notes, I wrote a plus sign above sodium. And then finding chlorine is going to be a non-metal since it was written second. And it's over here, atomic number 17. And you can see that chlorine is the atom and chloride is what we call the ion. So this one has a charge of -1. You can see in my notes that I wrote a negative on top of chloride. So what happens here is the two ones are already balanced. You need to have the same number of positives and the same number of negatives, and we do. So overall, if I put sodium and chlorine together, it makes sodium chloride with a charge of 0. It's balanced. That means that I'm going to write NaCl with the ones secretly being behind the sodium and the chloride. We don't write the ones. Just like in math, if we have an exponent of 1, we wouldn't write it. Let's try another one. So silver and iodine. Silver is going to be a metal and iodine a non-metal. Going to my data booklet to find silver, atomic number 47. The silver ion at the bottom has a charge of positive, and for my second one, iodine, right here, atomic number 53 has a charge of negative. So this is essentially the same example, a positive and a negative balance to make 0. So you're simply going to write your symbol for silver, Ag, and your symbol for iodine. And for now, we're putting a little subscript S in brackets, solid, behind all ionic compounds until we learn the next step. It's important to make sure that you've got your capitals and your lowercase correct because a lowercase g is very different than a capital G. All right, next example, we can see magnesium on our periodic table as a metal is right here at atomic number 12. At the bottom, the magnesium cation has a charge of positive 2. So I'm going to write that above magnesium in my work, and you can see it right there. And oxygen, same thing. If I look for oxygen in the nonmetals, I find it right here, atomic number 8, and the oxide ion has a charge of negative 2. So there's my charges. They already simplify. They've got 2 and negative 2 making 0, so they're balanced. And we're not going to write the 2's if they're balanced. If this was a fraction, 2 over 2, it would simplify to 1. So there are just secret 1's here that we don't write. So here we have magnesium and then the oxygen symbol. We write them together, no spaces, with solid after. In order to write the words, we write the metal as is, and spelling is important, so we copy it off the data booklet, and then we write the ion for the nonmetal with a different ending. So you can see these nonmetals, if you look at the ion at the bottom of the boxes, you can see that they all end in IDE. So your second word, your nonmetal, should end in "ide." Calcium and nitrogen, you can see that these charges off the data booklet are different. We have 2 plus and negative 1. So what we have to do for these to cancel is we cross the charges. What this means is if you go over here and you write calcium and you write nitrogen without any subscripts, what we're going to find is that the number for the first one crosses over to be behind the second one. The number for the second nonmetal crosses over to be behind the first element. So these numbers are both written behind the element that comes before them. Now this one kind of got erased in the notes, but nitrogen, as we can see, is a charge of negative 3. And calcium is a charge of positive 2. So behind nitrogen is going to be calcium's charge, 2, and behind calcium is going to be nitrogen's, 3. These should be subscript, tinier than the regular line of writing, and a little bit below the regular line of writing. Think the opposite of an exponent. Put your solid in brackets behind, and you have calcium nitride, changing the ending to IDE. The next example, zinc and selenium both have charges of 2, zinc being positive, selenium being negative. The 2's will cancel out and balance to give you secret 1's. This is a pretty basic example where you don't end up with any subscripts at all. Zinc selenide, changing selenium to selenide by changing the ending to IDE. And again, you can just copy from the bottom of the box on the periodic table the actual spelling. Next one, we have aluminium and fluorine. So aluminium has a charge of 3 plus, and fluorine is negative 1. So this is one where I would start by writing Al and F with nothing, and then I think the 3 belongs to aluminum. So the way that I'm going to balance this is by writing the 3 behind fluorine. So there you can see it behind fluorine. The secret 1 behind aluminum comes from the charge of 1 minus that fluorine has. Okay, put your solid and call it aluminium fluoride. And I've underlined this because lots of students like to write it as OU instead of UO. So be careful with your spelling. Another example here of potassium and chlorine both having charges of 1, and therefore we write no subscripts whatsoever. Potassium chloride is what it's called. Silver and oxygen is hard to see on these notes, but what we'll have happening is the secret 1 that belongs to silver crosses over and goes behind oxygen. The charge of 2 that oxygen has crosses over and will be behind silver. This compound is called silver oxide. Now, naming these, there's nothing more to this than writing the metal first. Don't change anything about the metal, and writing the nonmetal second with that ending of IDE. So magnesium chloride, cesium fluoride, cadmium oxide, magnesium bromide, potassium sulfide, and lithium phosphide. So all of these are metals in the first part, and all of these are nonmetals in the second part. Our next lesson that we did a few weeks ago was on multi-charge ionic. So some of the metals in the data booklet, like iron, lead, and copper, if you look at those, here we have copper and nickel as atomic number 28 and 29. If you look below, there are multiple charges that you can have for these metals. Something like zinc over here, this only has one possibility. Zinc will lose 2 electrons and have an overall charge of 2+. That's all that we're going to see happening with zinc. With copper, however, you can have it losing 2 electrons or 1 electron. It just depends what's going on and what ion it's joining to. So copper 1, copper 2, nickel 2, nickel 3. These are the only options. You're not going to have, say, a nickel 1. If it's not written in the data booklet, then we don't have any other options. Okay, so these are the only ones that this happens with. If you can see at the bottom of the box the Roman numerals in brackets next to the metal, then you're going to write those when you have an ionic compound that's multi-charged. If you don't see that, you wouldn't be calling this zinc 2. This is just zinc fluoride, say. But what you have to say for copper fluoride is you would have to say whether it's copper 2 or copper 1. So let's do an example. We have, for the first one here, lead and chloride, but we have to decide with lead if it's going to be lead 2 or lead 4. So we have to decide what charge this lead has if 4 chlorines are combined with it to make a charge of 0. So the first thing I'm going to look for is I'm going to look for the chloride ion. Here it is, atomic number 17, and it has a charge of -1. But you can see in my notes that I didn't write -1 above the chloride ion. I wrote -4, and that's because this subscript right here of 4 tells me that I actually have 4 chloride ions altogether. So if I have 4 of them, and each one is a charge of -1, that would make -4 total. So I wrote the total charge of all of these chloride ions. Then I said, how many leads do I have? There's a secret 1 behind lead telling me that there's only 1 lead ion in this ionic compound. That 1 lead has to balance the -4 that I have from the chlorides. So that means that if I look at where lead is, atomic number 82, lead has a possibility of being 2+ or 4+. I need to select the lead that will balance with my -4. So I'm choosing 4+ to make a charge of 0. So that means that when I write out the name, it's still metal first, non-metal with the IDE ending second, but you will have a Roman numeral in brackets in the middle, depending on which charge you chose. So for this one, this is called lead 4 chloride. Now you see essentially the same compounds, but this lead only has 2 chloride ions bonded to it, whereas this one had 4. If we only have 2 chlorides, each -1, that makes -2 total. And then the lead, the one lead that I have here, has to balance that and be 2. So this is lead 2 chloride, whereas before it was lead 4 chloride. Let's try this one. Starting with the nonmetal first, so the second one is oxygen. Oxygen, if I write the ion, oxide is a charge of -2. There's a secret 1 behind oxygen, so I only have 1 of them. So my overall charge for one oxide ion is -2. I have 1 tin ion that needs to balance with -2. So in order for that to happen, it has to be +2. That makes tin 2 oxide. When we're given the name and we want to write the formula, this is what we were practicing in lesson 4 with crossing the charges. For the metal, when you're dealing with Roman numerals, whatever the Roman numeral is, that's what the charge is. If we take a look at a few, Mercury 2 has Roman numeral 2. Mercury with 1 plus is Mercury 1. So these are always going to follow this pattern. Iron 2 will have a charge of 2 plus. Chloride, we looked up earlier, it has a charge of -1. And in order for these to balance, the charges must cross. So behind the iron is going to be the charge of chloride, 1. Behind the chloride is going to be a charge of iron, which is 2. Next one, chromium 2 is 2 positive, and the sulfide ion is 2 negative. These balance. 2 positives and 2 negatives would make 0. So we don't write any subscripts whatsoever. There's secret 1s when we're thinking about how many there are, but this is just CRS with the little solid behind. Manganese 4 fluoride. So when you see the 4, you know that's going to be a charge of 4 plus. Fluoride from your periodic table has a charge of -1. These charges do not balance. 4 and 1 are not balanced, so they need to cross over. So I'm going to write manganese, and I'm going to write the charge of fluoride behind manganese, which is 1, so we don't write it. The 4 goes behind the fluoride as a subscript, and you put your solid with it. So that's a review of what we've done a few weeks ago with ionic compounds. Next week, we'll move on to some more complex ionic compounds called polyatomic ionic compounds. But for this week, what I want you to do is 1 hour of practice with the ionic compound work we've already done. Chances are, if you go to lesson 4 and 5 in your practice booklet, you've already done most of those. If you haven't, start working on those. Start with 4 and work to 5. And check the website because the answer key for the whole practice booklet is posted on the website. Okay, again, this should be 1 hour of work this week. You don't want to work yourself too hard. And if you've completed all of them already, just redo a handful of questions until you get to your 1 hour of science work. Once you have these ionic compounds figured out, next week's lesson should be a little bit easier. Make sure that you contact me via email or Flipgrid if you have any questions, and I'll help you figure out how to name ionic compounds. Bye for now.